Hey everyone, welcome to this explainer. Look, today we are demystifying this tiny little device that is completely changing the game for off-grid communication. It's wild how much we rely on cell towers these days, right? For absolutely everything, from our GPS maps to text messaging to emergency weather alerts. True communication independence is surprisingly rare. When the grid goes down, most of our modern technology just turns into expensive paperweights. But today, we're going to explore how a remarkably simple piece of hardware is unlocking powerful, resilient digital modes for incredibly cheap handheld radios. Picture this scenario for a second. You're out hiking deep in the trails somewhere out west, or, I don't know, maybe up in the remote, dense woods of northern Wisconsin. You pull your phone out of your pocket to check in with your family, and 0 bars. No self-service, no internet. You are completely and utterly off the grid. If an emergency happened, or even if you just desperately needed to send a quick SMS text message or an email to let someone know you're safe, how would you actually do it without relying on a cell tower?
Now you might be thinking, okay, getting true off-grid comms means I need thousands of dollars of bulky satellite gear, monthly fees, and heavy equipment, right? Well, actually, no way. Thanks to some absolutely incredible open-source engineering in the amateur radio community, you can actually build a completely portable, standalone digital data hotspot for around $60. Yeah, let that sink in for a second. You can establish global or local digital communication capabilities for just $60.
Okay, let's dive into this setup. Here is the highly accessible shopping list for your $60 data hotspot. You start with an off-the-shelf handheld radio, like the wildly popular Baofeng UV5R or the Quansheng UV-K5. Those run about $23 online. Then, you grab a Raspberry Pi 02W microcomputer for about $18, add a basic SD card running the DigiPi operating system to handle the software side, and grab just a standard USB battery bank to power it all up. But the missing link, the absolute magic piece that seamlessly ties the radio and the microcomputer together to make the whole shebang work, is the AIOC adapter. Section 1. Meet the AIOC, the open-source magic gadget. This open-source creation by Simon Kuipers is what makes this entire revolution possible. So what exactly is this thing? Well, AIOC stands for All-in-One Cable. It's this remarkably compact USB-C adapter that plugs directly into the side of your handheld radio. And inside that tiny little package, it's doing double duty. It functions simultaneously as a virtual serial port and as a CM108 sound card, which, to put it simply, is basically just an incredibly reliable, low-cost audio processing chip. Because it has both of these built right in, it manages your incoming and outgoing audio data, as well as your push-to-talk trigger through one single USB-C connection. It completely eliminates that old, frustrating mess of needing one cable to program your radio frequencies and an entirely different clunky sound card setup just to interface with digital audio.
The sheer versatility this thing unlocks is just incredible. You can use a program like CHIRP to manage and program your radio frequencies right from your computer. You can fire up Direwolf or APRS Droid to send your exact GPS location and short SMS messages over the APRS packet network, which here in the US operates on a dedicated frequency of 144.390 MHz. You can even use software like Winlink or VaraFM to log into an AX.25 server. Now, if you aren't familiar, AX.25 is basically an awesome old-school data network operating entirely over radio waves. By using it, you can send actual real-world emails to anyone's Gmail or Outlook inbox without a single drop of internet connectivity. The AIOC literally turns a $20 radio into a digital Swiss Army knife.
Moving on to Section 2, AIOC versus the alternatives, the interface debate.
To give you the full picture here, we pulled this comparison neutrally from the DigiRig forums. DigiRig being a very popular alternative interface in the ham radio world. The AIOC is a true champion of simplicity for specific radios. It uses that driverless CM108 audio chip, creates a virtual serial port automatically, and perfectly fits the dedicated Kenwood K1 form factor, which is the plug style used by Baofengs and Quanshengs. Plus, it's much cheaper to build yourself. On the flip side, the DigiRig does require specific serial port drivers and cost a bit more, but its swappable cables mean it plays nice with a much wider variety of radio brands, like Yaesu or ICOM. It also allows you to physically move the radio further away from your computer. Honestly, both are excellent tools. It entirely depends on your specific radio setup. All right, Section 3. Simple setup and troubleshooting. Getting on the air.
Setting this up requires a few very specific steps to ensure your data packets actually transmit and receive. First, plug the AIOC into your computer. So, The crucial point is, you absolutely must use a USB-C data cable. You know those cheap phone charging cables? A lot of them are power only, and if you use one of those, your computer simply will not detect the AIOC at all. Next, set your radio squelch to 1. If the squelch is closed too tight, your radio will literally block out the incoming data packets before the computer even has a chance to hear them. Finally, dial your radio's physical volume knob to roughly 75%. Extensive testing by users shows that if the volume is too low or too high, the digital audio just won't decode properly.
Next up is a highly specific troubleshooting tip from a vendor called NA60. And honestly, this solves about 90% of the user issues reported online. They call it the click test. You have to ensure the K1 connector on the AIOC is pushed firmly into the side of your radio until you physically feel or hear a distinct click. The plastic molding on some of these cheaper radios can be a little tight, and if there is even a millimeter of a physical gap between the AIOC and the radio body, your audio or push-to-talk will completely fail. So give it a surprisingly firm push.
Now, what happens if your AIOC randomly disconnects from your computer the exact second your radio starts to transmit? Well, that is almost certainly RFI, or radio frequency interference. Think about it. If you're using the stock rubber ducky antenna right next to your Raspberry Pi, you're essentially blasting 5 watts of invisible RF power directly into a sensitive microcomputer. You're going to scramble its brains and drop your USB connection for sure. To fix this, just snap some ferrite chokes or beads onto your USB cable. Make absolutely sure you're using a high-quality shielded USB-C cable, or better yet, use a coax cable to physically move your antenna much further away from the AIOC and the computer. Real quick, for my Linux and Raspberry Pi users out there who are running software like Direwolf, there's one permission fix you definitely need to know. The AIOC uses a human interface device, or HID, to actually key the radio and tell it to transmit. To let your software access this HID protocol without needing root privileges every single time, simply add your user to the plug dev group using the terminal command shown right here. Once you run this quick line of code, just log out, log back in, and your software will happily trigger the radio to transmit whenever it needs to. Section 4. Build it or buy it. Acquiring the AIOC.
So you actually have a few great options to get your hands on version 1.2 of this hardware, depending entirely on your budget and your desired effort level. If you just want a seamless plug-and-play experience, you can buy a fully assembled and tested AIOC from NA60 for about $33. If you want to save some cash and don't mind doing a little through-hole soldering, they sell an unsoldered kit where the incredibly difficult surface mount components are already finished, and that's just $20. But if you want the ultimate ham radio DIY flex, you can take Simon Cooper's open-source Gerber files, which are essentially the digital blueprints for the circuit board, straight over to a fabricator like JLC PCB. For about $60, you can have a batch of 5 bare boards manufactured and shipped to you to build from scratch and share with your friends.
Let's actually look at the $20 NA6D kit for a second and see how this builds, because the assembly process is super clever. First, you drop the 2.5 and 3.5mm audio jacks upside down into a special 3D printed soldering guide that comes with the kit. Then, you snap the AIOC circuit board right down into that guide over the pins. And this brilliantly illustrates how thoughtfully designed the kit is. That simple 3D printed guide perfectly prevents any pin misalignment during the build. From there, you just solder the top signal lugs sparingly, flip the whole thing over, and solder the large bottom ground tabs for stability. Pop it out of the guide, and boom, you are completely ready to go. When you put all these affordable little components together, it's incredibly hard to argue with the end results. Craig, over at the widely respected KM6LYW radio channel, absolutely hit the nail on the head when he said, "This is the ultimate cheap and low-power radio data transceiver hotspot that you can possibly get." The overall value proposition here is just off the charts for the sheer amount of digital capability and emergency readiness it brings to modern amateur radio, especially for operators on a strict budget. So I want to leave you with this final provocative question to ponder as we wrap up. If traditional cell phone towers and internet networks went completely dark tomorrow, how would you actually stay connected to the people who matter most? Seriously, think about it. With just a $23 handheld radio, an $18 mini computer, and an AIOC, you've got the power to send emails, broadcast your location, and transmit texts completely off the grid. It's a fascinating, empowering project and a really fantastic way to ensure your own personal communication readiness in, let's face it, a pretty unpredictable world. Thanks so much for joining me on this explainer, and keep exploring out there.